Hey and welcome. Today we will solve find center of star graph problem. Let's get into it. Here's the first example. We have this graph represented to us as list of edges in array, and of course the center node is 2 here, so we will return this as result. Here's the second example. If we try to visualize this graph, we will have something like this, that in which the center node is 1 right here. We will go through two different solutions, so let's see how we are going to solve this problem. For the first solution, we will utilize the fundamental graph concept, which is the degree of a vertex or node in given graph. The degree of a node in a graph is the number of edges that goes in or goes out of that node. The ones that goes into the node is called in degree, and the ones that goes out of the node is called out degree. To count the degree of a node, we can track the frequency of each node relying on a hash map and count how many times a node appears in each edge representation. By the way, I have a video explaining how hash map works. It's actually a Microsoft interview question, so make sure to check that one out as well if you are interested. Well, enough of the detour. That is one side of the story, but the other thing is, the most dominant property of center node in the given graph is that it has been represented in every single edge, because every other node has to have an edge to the center node, right? That is how it's going to be placed in the center. We can clearly see that property if we visualize the given graph, like example 1 in here or example 2. So we can simply approach this problem by just forming the idea of what if we count the frequency of each node in represented edges, and whatever node that is going to be keep appearing in all of the edges will be the center node. That is our big hint here, because that is how a center node being defined. Okay, how we are going to find that node? It is simple. If degree of the node is the same as length of the array, then we know that is a center node. Let's code this solution now. Okay, here we are in Leetcode. For this solution, first we need a hash map to store degree of each node that appears. Then a simple iteration over given edges array, and for each of them we will pluck out source and destination nodes from current edge in iteration. Next, we will store frequency of each node in the degree hash map. And for the first time, since neither of source or destination node is represented in our hash map, we will store the default value of 1 for them. Okay, now we have our degree map ready for all nodes in the given graph. Next step is to iterate over this hash map, and whichever node that has connection to all other nodes will be our center node. As we have discussed, we are going to figure this out by checking if the frequency of a node is the same as length of given edges array, because that would mean that node has connection to every other node. And at the end, we would return -1 as an indication that there's no center node in the graph. But since the question says that the given graph is a valid star graph, we will not going to hit this scenario, but just for the sake of completeness, we will return -1 at the end. Now, if I run this, tests are passing, and if I submit, we are in a good shape here. But for a moment, take a look at runtime here. Actually, we are going to fix that next. Back to the slides now. For the second solution, let's escape the entire graph world and think simply for a second. As we have discussed previously, the most dominant property of a center node in a given graph was that it has connection to every other node, so it's definitely going to be represented in every single edge. So we might ask ourselves that, given this property of a graph, is there a more optimized way to find out the answer? Because the big issue with the previous solution was that we were iterating over all the nodes and our frequency map was taking space. The answer is yes, of course, we can. In that case, our solution is going to be a little bit different, but more efficient. We already know that all nodes will have a connection to the center node, right? This is guaranteed in our case. So what if we only compare source and destination nodes in 2 edges with each other? The first and the second edge, for example, or any other edges in a given array. If we do so, the duplicate value in both edges will stand out so quickly, and we will end up finding the center node without iterating the entire given array, because whatever node is represented in any 2 edges, that is going to be the center node. That's simple. So let's jump into the code to implement this solution. Okay, we will start by getting first and second edge into their own specific variables, and of course compare their nodes with each other. Let's walk through an example since it's clear to see rather than me just explaining stuff. If we take 2 edges from second example, we can see that if source node from first edge is equal to source node from second edge, which is not, or source node from first edge is equal to destination node from second edge, which is true, then the source node from first edge is the repeating one and we should return it. Otherwise, the destination node is what we are looking for. Like in a scenario in example 1. As you can see, source node from first edge is not equal to source node from second edge. as well as source node from first edge is also not equal to destination node from second edge. So both checks are going to fail, and what we are left with is our only option, which is the destination node from first edge, and we are going to return it as result. And the code for those checks is going to be look like this. Now if I run this, test cases are going to pass, and if I submit, everything is going to be green. Let's jump into the slides for time and space complexity analysis. So the time complexity will be O of n for hash map solution because we did a linear iteration on the given edges array, and optimized solution will have O of 1 because we just used some variables to compare values. And the space complexity will be O of n for hash map solution and O of 1 for optimized solution. That was it for this video. Thanks for watching, and please leave a like, comment and subscribe to the channel. I will put a few more links about different playlists in the description for you to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.